Getting started with our conservation webinar, I'm Holly Kirkendall, National Technology Specialist for NRCS's East National Technology Support Center. I'm pleased to turn the webinar over to David Lamb. David is the National Soil Health Team Leader for NRCS's Soil Health Division, and David is also located in Greensboro. David, you may now begin.
Okay, Holly, and thank you for that nice introduction. I want to welcome everybody to today's webinar. And I think today's topic is very timely. How do pest management tactics influence soil health? As we go around, actually I'm in Richmond, Virginia this week doing a course on soil health for our NRCS employees, and we talk about an ecological approach to farming, in which this plays right into it. And I think you've got a really excellent speaker. If you've done any Googling of pest slugs and pest management, you'll probably find Dr. John Tooker's name pop up on a number of sites out there. Dr. Tooker works for Penn State University. He's been there since 2008. He's an associate professor of entomology and an extension specialist there. He's received numerous degrees, starting with a BS from Bates College in Maine, and he received his master's and Ph.D. from the University of Illinois in Champaign, Illinois there. So with that, just want to remind folks we're going to hold questions until the end. You can type them in the Q&A pod there, and we'll answer them as we can there. But with that, Dr. Tooker, I'll turn it over to you.
All right, David, thank you very much. And Holly, thank you for handling the logistics. Nice to be with you this afternoon to talk about a topic that I don't know if it gets much attention out there, but we've been studying it here for a couple of years now at Penn State, and I'm happy to share with you some of my thoughts and research on the topic. So the image on your slide there is a jumping spider, and that's not false color or anything like that. That's the true color of the jumping spider. Those fangs or chelicerae are actually that greenish blue color, which I think is kind of cool. But these are the types of animals that I hope you guys have appreciation for and try to foster in crop fields, because they can help with pest control. I'll start with the take-home messages, and there are 5, and they're fairly straightforward, and I hope that some of them are intuitive. First one is simply following along with NRCS's promotion of soil health, and that is that healthy soil improves crop productivity and quality. I hope that's not a surprise to anybody. To promote or to grow soil health, we use no-till, diverse rotations, and cover crops, but I'm adding a 4th important piece called Integrated Pest Management. I think that's a vital piece. It needs to be included, and for the large part, I don't hear much about it, so I'm going to bring attention to that today. A 3rd piece is that soil is alive. Healthy soil, in particular, is very alive. We need to foster that life to improve crop production. And then pesticides, and by pesticides I primarily mean insecticides and fungicides. They will limit soil health. So to use pesticides, we want to use IPM or integrated pest management wherever possible to guide that pesticide use. And as a starting point, I like to remind everybody that one of the predecessors of agriculture in terms of the habitat we've taken over are tallgrass prairies. And tallgrass prairies are among the most productive ecosystems in the world, just in terms of above ground and below ground biomass production. And they have this diversity in space and time in terms of plant species diversity that drives everything that happens out there. Besides just space and time, they have a diversity in form, so different plant sizes and shapes and heights. And in this diverse environment, herbivore outbreaks are very rare. And that rarity comes from that healthy plant community, the strong interactions among plants, but also the community that builds upon the plants. So there's healthy herbivore populations, but even more importantly, there's healthy natural enemy populations. So if anything is eating a plant, the plant is fighting back against that, but then also something's looking to eat that thing that's eating the plant. So it's this very diverse environment where it's going to be eat or be eaten approach to life, I guess I would say. In this environment, a complex food web builds. That complex food web is driven by organic matter. That organic matter supports the base of the food chain, which are largely bacteria and fungi. Bacteria and fungi then, of course, support higher levels in the food chain, and then this interconnected web builds. where things are eating other things. And if you take away any particular level, you're going to take also away the layers that are on top of that level. So valuing this food chain becomes very important when you're trying to understand kind of population dynamics and interactions that occur in one of these complex ecosystems. If you contrast all that diversity and those strong interactions with what occurs in modern agriculture, you see quite a different thing, and I think this comparison has value. So in a modern agriculture, farmers often seek solution via their inputs. They typically don't assume that interactions can help solve their problems, but in these simplified settings, herbivore outbreaks are common. I think that's a safe statement. And when we go from a complex system like a prairie to modern agriculture, which in many cases is occupying the same footprint, simplification occurs. So we have fewer species in the mix. When we're dealing with, say, soybeans or corn, we just have soybeans and corn there, and most farmers are awfully good with their weed management program, so plant species diversities are usually quite limited just to the crop we're trying to grow. There's very little genetic diversity because even with corn, for example, we have inbred hybrids. We're taking that genetic diversity away purposefully, so everything comes out of the ground uniformly and it matures at the same time, it pollinates at the same time. But that genetic diversity is quite a lot different than what you'd find in a prairie when genetic species diversity is quite high because there are different varieties of the same species. Typically in an agricultural system, natural is replaced with synthetic, both in terms of fertilizer and pesticides. These modern agricultural systems have a whole lot less organic matter input, so prairies, again, are producing a lot of above-ground and below-ground biomass, which is feeding the soil. And then because of that, there's this weaker soil-based food web in agricultural systems. But even though we can simplify, or agriculture has been greatly simplified, there are certain things we can do to improve the diversity there. And one of the things that I advocate for as much as possible is no-till. All right, so no-till makes conservation possible, and it's the first step along the path to soil health. No-till is typical in Pennsylvania. About 80% of the crop fields in Pennsylvania, the large acreage crop fields, are in no-till, and I think that is a very good thing. It provides all these benefits we could list, but I'm just going to focus on this one, that it provides stability, and that stability provides a wonderful habitat for beneficial organisms. So in this kind of growing soybean field, all that residue there not only is helping prevent soil erosion, but it's also providing habitat for beneficial organisms, whether it be detritivores, earthworms, or beneficial insects. And then if you add cover crops to the mix on top of that, you're just enhancing the habitat as far as I'm concerned. Those cover crops better foster this food web that can build, and that food web in the end becomes a farmer's friend if it's allowed to be. I don't have to tell most NRCS employees this, but you know that soil is a home. It breathes. You can measure the respiration rate of soil. But recognize that what's alive in soil are animals, microbes, that are sensitive to management. You've probably seen facts like this before, but I just list a couple here that I borrowed from various sources. And in a teaspoon of soil, there are just millions and millions of alive organisms, whether they be bacteria, fungi, protozoa, nematodes, arthropods, or earthworms. And I emphasize this just to say that if you think about pesticide use just for a second, the prime things to think about are the fungi and the arthropods, but it's clear that for some organisms they are susceptible to insecticides and fungicides, not just fungi and arthropods. There is evidence that earthworms aren't as active in soils that have been regularly dosed with various insecticides. So there are these kind of cross-phylum interactions that occur. So we know that soil's alive, right? And now we have this concept of soil health. It's been around a little bit longer. I just wanted to emphasize a couple things here. You guys know that soil health is defined as the ability of the soil to sustain biological activity, water and air quality, and the health of plants and animals. We could come up with other definitions if we liked, but this is one that works kind of for me. And soil health is found at the intersection of the biological, physical, and kind of chemical aspects of soil. And by chemical, I don't mean synthetic chemicals, we mean nutrients. My talk today is going to focus largely on the biological portion of soil. And to build soil health, most NRCS employees that I run across talking about soil health or other advocates for soil health, whether they be farmers or other extension folks, what have you, they kind of set upon these three tactics or approaches to farming that can be used to build soil health. That's no-till, diverse rotations, and cover crops. That no-till is important because we're building soil structure and stability. The diverse rotations and cover crops work together to increase organic matter, feeding that soil food web and assisting with pest management. That's one that I added that's not always included. But again, back to this idea that no-till makes conservation possible. A lot of farmers that don't do no-till, so they regularly do tillage of some form, often ask me the question, well, if I move to no-till, doesn't that make my pest problems more challenging? And we've done some work in this realm, and the answer is no. It doesn't really make your pest challenge different. It doesn't make it more challenging. It makes it a little bit different. So in a no-till system, these are the kind of 5 pest species that really kind of come to mind for me. So black cutworm, true armyworm, stalk borer, wireworm, and slugs are the things you kind of have to look out for. In a tilled system, you'd have a different list here. So it's not that no-till system, the pest populations are worse. It's just that the pest populations are different, and those different pest species bring some challenges with them. But as I mentioned in the opening, I would add one more item to this list of ways to build soil health. We're going to do no-till, we're going to do use cover crops and diversify rotations as much as possible, but I don't think you're really achieving soil health fully until you incorporate integrated pest management into the mix. That's because integrated pest management provides a framework to apply pesticides if necessary, but we're applying them in a way that protects the beneficial organisms that are in those fields. Those beneficial organisms that can be allies, whether it be in nutrient cycling or in pest control or what have you. So the primary actors here will be fungi and arthropods, but don't ignore the worms. These guys are contributing important details when it comes to soil health. Those fungi and arthropods working together can help soil aggregation, nutrient cycling, and pest control. And that with indiscriminate pesticide use, the function of these two groups will go down. So let me provide a little historical context that perhaps you haven't encountered because you haven't studied integrated pest management in grad school the way that some of us have. But just as a reminder, integrated pest management is using a combination of biological, cultural, and chemical tactics to manage pests. And integrated pest management has been used to manage cockroaches in urban centers, starting to be used to manage cancer in a medical arena. It's used to manage all manner of pests across the globe. But it has its roots from a group of entomologists at the University of California, Riverside, who introduced this concept of IPM to the world in 1959. They introduced it in alfalfa against a pest called the spotted alfalfa aphid, which is a pest that's common in the eastern United States but rarely causes economic damage. It's more problematic in the West. And IPM was introduced to do one thing, and that was to eliminate calendar sprays. So if a calendar spray is just what it sounds like, we're spraying our crop on June 1st because the timing is right for us, or that's when we always do it, or whatever. But if we eliminate calendar sprays, then we reduce challenges from resistance. We do reduce challenges from pollution, whether it be environmental pollution or more specifically water pollution. And if we reduce calendar sprays, then we reduce non-target effects. And those non-target effects can come in all kind of shapes, forms, and sizes. Back when DDT was being used, those non-target effects involved the health of raptor populations, and that got a lot of press as osprey and bald eagle populations plummeted. But when I talk about non-target effects, I typically talk about natural enemy populations. So we want to use IPM in part to help reduce the impact of insecticides on natural enemy populations, other good animals in crop fields that can be useful to crop production. So that's just a little bit of context on what IPM is and kind of where it came from. Its main goal was to reduce the blind use of insecticides so we didn't have kind of this cascading list of challenges that includes resistance, pollution, and non-target effects. So if we respect life in soil, it'd be good to recognize what we're talking about. And I'll just talk about two broad groups of animals we find in the soil. The first is just the soil microfauna. So these are the small little guys that are often microscopic, or at least smaller than a grain of rice. And these guys, whether they be mites or nematodes or collembolans or even cool things like pseudoscorpions, are controlling decomposition either directly or indirectly through their action of shredding organic matter or eating things that shred organic matter. They're helping mineralization to make minerals more available to plants. They're fragmenting that soil organic matter. They're helping create soil structure. They create soil organic matter through their fecal pellets, and they provide biological control. There are a lot of predatory mites that can be very important in controlling, say, spider mite populations if they pop up. The next group to think of are the animals that are slightly bigger than that. So these are the soil macrofauna, and they include things like earthworms that, of course, have been called ecosystem engineers for all the kind of tillage they do, moving through soil, moving soil around, creating pores and channels. They too are producing soil organic matter by making their fecal pellets. They're helping create soil structure. There are a lot of subterranean insects that burrow through the ground, looking for things to eat. There are some herbivores down there as well, but mostly we're focusing on the good animals down there. They're increasing soil organic matter, and they're contributing to biological control. Grouped within this category of soil macrofauna are the ground beetles. I just highlight ground beetles because I'll talk about them a little bit today. They're awfully important when it comes to pest control. They'll eat a wide range of things, from caterpillars and aphids. They'll even eat slugs, things like black cutworm and armyworm. And some of them are omnivores. They'll actually eat weed seeds if given the chance. So they can be nice allies in pest control. I like to focus on ground beetles because they can be particularly abundant in no-till systems. They've been called the lions of no-till fields. Now, that might be a stretch for an animal that's might be an inch long maximum, but they are really voracious predators, and one of the things that make them important is that their larval form and their adult form are both predaceous. So here is the larvae in the upper left-hand corner. That is a subterranean animal that burrows through the soil trying to eat anything it can get its mandibles on. And the adults on the lower right, that's obviously a beetle, given the hard shell on the back, on its abdomen, but that too will run around the soil and eat whatever it can get a hold of, whether it be an armyworm, a slug, or a weed seed if it's so inclined. And these guys will eat those same 5 pests that I listed as being common in no-till systems, so it's a nice match. They'll eat all those things, and it's particularly notable that some species even specialize on slugs. So if you can maximize those populations in sluggy fields, then these guys can do a nice job of pest control. Okay, so let's, with all that kind of background, let's consider insecticides for a moment. I consider insecticides as valuable tools, but a lot of folks see farming without them as near impossible. So I find these to be tools that can be valuable, but historically they have tended to be overused. And they've been overused whether they're applied to the leaves, whether they're applied to soil, or they're used as treatments that are put on seeds. I would like insecticides to be used in this integrated pest management framework to maximize their value. So rather than use them blindly, let's use them wisely to optimize their value. If we don't, there are these unintended consequences, which are similar to or the same as the unintended consequences that occurred that really hastened the development of integrated pest management to begin with back in 1959. So if we don't use them wisely, we're going to decrease the good insects in the fields that can leave our fields more vulnerable to bad things, and then there are environmental concerns. Water pollution kind of chief among them, but non-target effects of decreasing populations of good insects kind of across the landscape. I understand in previous weeks some of these topics have been touched upon, so I'm not going to go into them in great detail. But suffice to say, there's research, kind of recent research and ongoing research exploring kind of the amounts of neonicotinoid insecticides in water, for example, and it's far greater than most people realize. And just one more statement about insecticides here, and that our research has shown that the influence of foliar-applied insecticides, soil-applied insecticides, and insecticidal seed treatments is about the same. So the negative influence on the beneficial arthropod communities in fields is the same, whether we're using a broadcast foliar application of insecticide or we're just using the seeds that happen to be coated with the neonic insecticides. The negative influence on the arthropod community is the same. Okay, here's a complicated figure I'll try to walk through quickly. These data are from a colleague of mine named Kyle Wickings, who's a soil ecologist at Cornell. And these data came from a turf system, so they don't translate perfectly to crop system, but I think they're instructive. So on the various axes here, we have different, what you could call ecosystem services, macro decomposer density, decomposer density, predator densities, mycorrhizal colonization, endophyte colonization, phosphatase activity, and so on. And then in the different colored lines, you see whether it's high use of insecticide, medium use of insecticide, low use, or no use of insecticide. And you can see on average, the functioning of this system is the highest when we don't have insecticides there. So that green polygon kind of encompasses the largest area. As we slowly increase the amount of insecticide put in the system, the function of these various axes kind of goes down. So at the red, which is the highest input of insecticide, we have the lowest ecosystem function. Okay, so it just provides insight that the more insecticide we put in the system, these various functions do go down. Okay, so let me take another turn here and talk about the neonicotinoid seed treatments. I understand in previous weeks you've also heard about these things, so I'll kind of go through this quickly, but just to make sure everyone's on the same page. We're talking about the active ingredients imidacloprid, thimethoxam, and clothianidin, whose active ingredients are gaucho, cruiser, and poncho, and they haven't been around that long. They were first introduced back in the late 1990s to the early 2000s. And these things certainly may protect yield when they're applied to seeds, but the key is for them to protect yield, the pest populations have to be present, and that's not always the case. They appear to provide a nice targeted application because you put the insecticide right on the seed, that seed's put in the soil, and then when the radicle and then the root starts to grow, the insecticide is taken up systemically by the plant. So this systemic activity can have benefits because things that bite the plant when it's a seedling can get a dose of the insecticide. When these things were first introduced, non-target effects appeared to be unlikely. We know now that that's no longer the case, and I'll provide a specific example of that. And they kind of breeze through the registration process because they have a very low dose, and they have relatively low mammalian toxicity. This is the list of pest species that are targeted by neonicotinoid insecticides on corn and soybeans. These are secondary pests, which by definitions are not your primary concern if you're growing corn and soybeans. The pests that are underlined are the species where neonics do particularly well, and the ones in parentheses are the ones where they do poorly. And I just noticed an error here. The aphids should be in parentheses also. So they do particularly poorly against black cutworm and aphids. But I would say on average, most farmers aren't losing a lot of sleep over these particular pest species. The one exception might be black cutworm, but since black cutworm isn't controlled that well by these seed treatments, they shouldn't be hoping that they get control out of it. But this is what we see in Pennsylvania, and a lot of my colleagues, extension entomologists around the country, see the same thing. So this is yield on the y-axis for untreated soybeans, soybeans that received a low rate of thimethoxam, which is the active ingredient in cruiser, and then the high rate of cruiser. And we see about equivalent yields. And this this finding has been backed up by the Environmental Protection Agency, who released a statement on the value of neonics in soybeans a couple years ago. But the reason we see this isn't because the insecticides don't kill things, it's because the pest populations are awfully low. And I just wanted to share with you some trends in pest management use over time to emphasize a couple points here. So here in this figure we have on the y-axis the percent of corn acres in the United States. And then we have from 1996 to 2013. 1996 is the year that Bt corn was introduced. Bt corn, of course, is transgenic insect resistant corn, primarily targeting the European corn borer to start out, but that has broadened over time. And this figure shows adoption of Bt corn over time and then a simultaneous decline in conventional insecticide use. So that's insecticides either applied to the leaves or to the soil. So just taken by itself, this figure shows that Bt corn adoption has decreased insecticide use. And that's real. These data are solid until you consider the neonic insecticides. If you put the neonicotinoid insecticides on that chart, you see quite a different picture, and you see an intensification of insecticide use over time. And I promise you that the insect complex that was being targeted in the late 1990s and then in the say 2011, 12, and 13 is the same. So this adoption is not driven by risk from insects. It's driven mostly by marketing and the whims of large companies. And if you look at this on a national scale, in corn, this is clothianidin use in 2003, so that map is blank. So there's no clothianidin used in 2003 across the country. And then that's what it looked like in 2011. If I was just recently, 2014 data came available, and this map is similar but just darker red, so just more is being used. And this is being driven entirely by corn. So this figure said the estimated use in millions of pounds over time, and the different colors are the different crops. So you can see that that is driven by corn. So these data are from the U.S. Geological Survey, and these maps are readily available on their pesticide use website. You can see a similar pattern in soybeans. Soybeans hasn't had a lot of insecticide use historically, so from about 1991 to about 2000, insecticides really weren't used in soybeans. Less than 3% of soybean acres in the country ever saw an insecticide. That's one of the benefits of growing soybeans back then, was that they didn't have insect pests. When I was in grad school at the University of Illinois, one of the reasons to grow soybeans was they didn't have insect pests. You didn't have to worry about inputs as much. But that changed a bit in 2001, when soybean aphids showed up, and then we've had this steady increase in foliar-applied insecticide over time. But the seed-applied insecticides became available in 2006, and they've been steadily adopted. But again, the pest population that can be targeted by seed treatments is the same at the tail end of this time frame to the beginning of this time frame, because soybean aphid is not controlled well by seed treatments, and brown marmorated stink bug, which has showed up recently, isn't controlled well by seed treatments either. So again, this adoption rate of insecticidal seed treatments is driven by marketing and the whims of big companies. This is what it looks like on a national scale. This is the amount of thimethoxam, which is the active ingredient in Cruiser. That's the amount of thimethoxam back in 2002. And then 2011 shows quite a drastic increase. And again, if we showed the 2014 data, it would just be a similar map, but the colors are even darker. So it's just a lot of insecticide use, from my perspective, without much reason. This pattern for thimethoxam is driven by soybeans, a little bit by corn, but also by cotton. Okay, so you're probably wondering why I'm telling you all this stuff, but it's just to provide some context. It's on the scale of deployment of the dominant insecticide in field crop production, which are the neonicotinoids. Okay, so that brings us to slugs. A lot of our research recently here at Penn State, my research group, has been on slugs. And slugs are significant in Pennsylvania in part because of the large acreage of no-till that we have. I already touched upon that. And then we get a lot of moisture in Pennsylvania. Some of our moisture, I understand, is the envy of other states, but it can be a drag to some farmers. And this picture shows one of those drags. So this is a picture that I've circulated a fair bit, but this is slugs on the front of the hay mower. A lot of people see that and don't really slugs, but you can see the individual slugs down at the base of the mower, and it kind of grades into this impressive sheen of slugs. So this is from a grower who went through a mixed alfalfa grass hayfield in the evening in the spring of 2012. He didn't realize he had a slug problem, but he knew the field wasn't yielding as well as it could. So he has slugs. And this picture emphasizes that slugs can grow to be fairly large in Pennsylvania. And there's a slug. That's the gray garden slug. Some people don't think it's a pretty animal. I have a soft spot in my heart for slugs. They are an attractive animal if you let it kind of into your heart. But one thing to emphasize is that it's a mollusk, right? So slugs are mollusks. They're not insects. Many people may not recognize that, but let's say it out loud. Slugs are more closely related to snails. They're essentially snails without shells, and they're more closely related to bivalves like mussels and oysters than they are to insects, which of course are in different phyla. So these are mollusks. Insects are in the phylum arthropods or arthropoda. And I'm just going to use slugs here as a case study. I strongly feel that if we can figure out ways to control slugs, then other pests should be a whole lot easier, because you can't go to the corner chemical store and buy very many things to control slugs. They're very frustrating pests to control. There aren't very many things you can spray, if any at all. So just to provide some context for those of you across the country who don't deal with slugs regularly, slugs can damage most anything they want. Canola seems to be like candy to them. They really enjoy soybeans, alfalfa, and small grains. They don't do very well on corn. Actually, if you give them a choice between corn and something else, they'll choose something else typically. And they tend to lose weight on corn. And one of the reasons they're really hard on corn is because they need to feed more on corn to get the nutrients that they really need. By a University of Delaware estimate, about 20% of the no-till acreage in the mid-Atlantic states suffers from yield loss every year, which equates to about 600,000 acres. So it's not nothing. Soybeans are particularly susceptible to slug damage because their growing tip is above ground and available. This lower left-hand picture shows slugs that have decimated the side of this soybean field. Corn damage looks a little bit different. It's this shredding type of damage along the leaves, and that's often borne out at the population level for corn, where you see these kind of empty spots in fields where there's a lot of residue, or that field tends to lie particularly wet. But this is what we see when you combine the neonicotinoid insecticides with slugs. And this is a picture of, these are data from our Central Pennsylvania Research Farm at Penn State. The vertical axis shows the number of slugs per trap, and to trap slugs we use pieces of white roofing shingle. So we cut them into 1 by 1 foot sections, and we just throw them in the field as an artificial shelter. So this is just the number of slugs under each of those pieces of shingle over the corn growing season. And in red, we have corn grown with clothianidin on the seed. So that's poncho. Again, the active ingredient is clothianidin, and the blue is an untreated seed. On average, over the course of the growing season, we see more slugs where we have the insecticide to where we don't. Recognize two things: that insecticide is not meant to control the slugs, but also recognize that the farmer who pays for clothianidin on their seed is expecting to get pest control benefits from it. And here we see the opposite. They're actually making their pest populations worse by using it. So now I'll go into a little bit more detail on a very similar experiment from the data I just showed you. These data were collected in a soybean experiment in 2012, again in central Pennsylvania, and we had 12 plots. 6 of them were treated and 6 of them were untreated. The treated plots received Cruiser Max on the soybean seeds. So Cruiser Max is a combination of 2 fungicides and thimethoxam. Again, thimethoxam is the insecticide in Cruiser. In this case, we use quarter-acre plots. They're much bigger than the average small plots that most insecticide kind of studies are done in, or most entomologists use. These were planted on 30-inch rows, these soybeans, so we could walk up and down the roads and do our research there. And I'll walk you through 4 figures, and I'll describe the axes just so everyone gets what I'd like you to see. This figure shows yield of soybeans versus number of soybean plants per acre. Okay, so as the number of soybean plants per acre on the x-axis goes up, yield on the y-axis goes up. That's a good thing. We'd be bothered if that wasn't the case. But this is a field experiment, and notice the strength of that relationship between these two things. But then also notice the color of the dots. The black dots are where we have the insecticide in the system. The open circles or white circles are where we don't. So we're seeing higher soybean yield where we don't have the insecticide, and that translates to more yield per acre. Then if we connect this to slugs, slugs now are on the x-axis, number of slugs per trap. That's the same shingle trap I talked about before, and this is number of soybean plants per acre. So as the number of slugs goes up, the number of soybean plants per acre comes down. And slugs are disproportionately harder on soybean fields where we have that insecticidal seed treatment. So where you see the black dots, again, where the insecticide is on the seed, we have more slugs, fewer plants per acre, which would translate to less yield. Now let's bring the predators into play. On the x-axis here we have the number of slug predators per trap. These are a different type of trap. These are called pitfall traps. It's just more or less a cup that we sink into the ground, and the predators bumble into that, and we can just collect them and go count them. And the vertical axis here is predation. To measure predation, we take a waxworm caterpillar, we put a pin through it, and we put that pin into the ground. Then we come back later to see what's eaten it. Here, the larger the number, the better. If we did this experiment perfectly, we'd be putting slugs on pins, but that's more difficult because slugs don't have an exoskeleton. They actually pull themselves off the pin. So somewhat embarrassingly, we haven't figured out a way to confine slugs to a spot, allow predators to come get them, and then we can come back and check to see if they're present or absent. So we do this with insects. I assure you we've tried a number of things from salt to copper to tethering them, and nothing seems to work. So we use caterpillars here. But anyway, the larger the number, the better. So the more predation, the better. So here we see as slug predators per trap goes up, predation goes up. But on average, we have more slug predators and more predation where we do not have the insecticide coated on the seed. And then connect this directly to slugs. Here is that same predation number on the x-axis. Again, the larger number, the better. And versus the number of slugs per trap. So as predation goes up, the number of slugs per trap comes down. And again, on average, where we have no insecticide, so no insecticide coated on the seed, we tend to have more predation and fewer slugs compared to where we have insecticide on the seed, which has less predation and more slugs. So this is a case where these insecticides are disrupting biological control. We know the mechanism behind this. We know that slugs are feeding upon plants. The plants are passing the insecticide to the slugs. The slugs are not susceptible to neonic insecticides, and then these predators come along and attack the slugs and get the insecticide from the slug. So it's actually being passed through the food web, and that's disrupting biological control, limiting the population of predators that are there to help control slugs. So when I give extension talks and talk to farmers, I encourage them to manage for the pests that they have. Right? If they have slugs, then one of the best things they can do is remove insecticides from the fields where slugs tend to accumulate. If wireworms are your primary concern, then the insecticide probably has value. But if you're rarely encountering wireworms, but you're always encountering slugs, then that insecticide isn't helping you at all. So again, manage for the pests that you have. Insecticides do not always help. Sometimes they harm. So a better way to deploy insecticides would be to use integrated pest management. That would be to deploy the insecticide just when it makes economic sense. But it's also good to recognize that insecticidal seed treatments aren't usually used that way. But I think there's an opportunity with farmers that believe in soil health to do just that. Just use treated seeds when it makes economic sense. Let me go over a couple more kind of case studies of when kind of diversity and ecological pest control can be of value. So I mentioned earlier that no-till crop fields in Pennsylvania and the Mid-Atlantic more broadly provide stability and diversity that give natural enemies a chance to be effective. Here's some information from a study that was done at the University of Delaware. It was a 6-year study done a couple years ago now, almost more than a decade, where they compared of rotations. And they used either IPM or they didn't. The first rotation, which I guess really isn't a rotation, is kind of continuous corn production where they deployed insecticides preventively. That is, they put them on blindly whether they need it or not, which of course is a practice that many farmers use. They compared that to a corn-soybean rotation, a corn-soy-wheat rotation, a corn-soy-wheat rotation with cover crops. In this last rotation, they deployed IPM, so they only put insecticides out when it made economic sense. When the economic thresholds were exceeded, they put it out to protect their crops in terms of a rescue treatment. And not surprisingly, the worst pest populations in this study were where they had continuous corn. And the lowest pest populations were in the most diverse rotations with cover crops where they deployed IPM. At Penn State, we've had a project in place now for going on its 7th year, something called Penn State's Diversified Dairy Cropping Systems Project. I am just a bit player in this effort. It's led by an agronomist named Heather Karsten. I'm the entomologist on the crew. And in this system, we're comparing two different types of rotations. Two 6-year rotations that are very diverse, include alfalfa, cover crops, corn, and small grains, to a simplified corn-soybean rotation. So it's not really much of a rotation. It's just corn, soybeans with no cover crops. So it's very conventional and typical of some farms in Pennsylvania. And as far as insect and slug control goes, the 2-year rotation is using all the inputs you would expect. We're using BT corn there. We're using seed treatments on both the corn and the soy. And when we plant both crops, we're putting out a pyrethroid broadcast application, much like farmers tend to do. In the two 6-year rotations, we're using IPM. So we're not using BT, we're not using seed treatments, we're only using insecticides as necessary based on our scouting and what the pest populations tell us. And much like the University of Delaware study, we're finding the same thing. So pest populations are worse in this 2-year rotation compared to the more diverse rotation. Those more diverse rotations break pest life cycles and they foster better populations of predators that can be allies in pest control. So what I ask growers to do is scrutinize and optimize their insecticide use. And that's not just soil seed-applied insecticides, it's also broadcast insecticides and soil-applied insecticides. I ask growers to ask themselves what they're trying to accomplish there, what specifically are they controlling, and do they know that their inputs are actually providing a benefit? Oftentimes they don't, and I further emphasize that integrated pest management can be an approach to protect those allies in pest control. They can also decrease our input costs because by putting out insecticides more selectively, we don't have that recurrent bill every year unless a pest population shows. So that means scouting for populations, understanding what your local pest population is, applying economic thresholds, which are available from Penn State Extension and many other extension organizations across the country, and then use those insecticides only when the economic threshold is exceeded to avoid disrupting natural control. Just a side note, usually when I give a talk like this, people ask about the seed-applied fungicides. So you all know that when you buy a treated seed, it's not just an insecticide or just a fungicide. It's usually a combination of the two. It seems that research is saying that the fungicides provide a little bit more value than the insecticide. However, I think that should be taken with a little bit of caution. It certainly has been shown that these insecticides can limit mycorrhizal fungi in fields. They can also limit the decomposition of weed seeds. So more research needs to be done in this realm, but it's not all benefit that you get from the fungicide applied to the seed. There are these risk-benefit analyses that researchers have done, and for the most part, they show that there's more of a benefit to a risk when it comes to the fungicide on the seed. That's not the same when it comes to the insecticide. The insecticides don't hold as much benefit as the fungicides. Okay, so then to broaden back out here, we know that tillage strongly influences soil-dwelling animals. So the logical approach then is to avoid tillage and use no-till, and that no-till provides stability and resilience. That stability and resilience drives higher populations of decomposers and predators that can then drive down pest populations. So we're benefiting from ecological control. And if we throw cover crops into the mix, we foster even more interactions, we drive more organic matter into the system, and we kind of drive the soil community even more, building up this food web, which can be beneficial when it comes to pest control. So some final thoughts. So if we want to build soil health, right, no-till rotations, diverse rotations with cover crops will generate these active, stable soil organic matter pools. The diversification of crops and habitats and organic matter inputs are beneficial, and then the crop rotation will help interrupt pest life cycles, and the animals we care about in soil will benefit even further by these reduced soil disturbances, perennials in the rotations, and then reducing insecticide and fungicide use as much as possible. So I want to make clear that I'm not advocating for avoiding insecticides and fungicides altogether. I would like them to be deployed as necessary based on scouting of fields so we have a good understanding of those local pest populations. And then they can be deployed as possible. In those cases where we know certain fields are going to have subterranean pest problems, then those would be the spots to target for treated seeds rather than just using them on every acre. As it stands, almost every acre of corn in this country sees these neonicotinoid insecticides. And I'd be surprised if anyone on the phone today would agree that every acre needs those insecticides. So a more targeted approach is going to have beneficial outcomes in the end. So I will end with my take-home messages, which are the same what I started with, but just to reiterate, healthy soil improves crop productivity and quality. We kind of know that. To build soil health, three things have typically been pushed. That is no-till, diverse rotations, and cover crops. I would add integrated pest management to that list because if we're trying to build soil health, blind pesticide use is kind of counterproductive because healthy soil is alive. And if we're trying to benefit from the arthropods and from the fungi and other animals that live there, I know fungi aren't animal, but let's just leave it at that, then putting insecticides and fungicides in that soil blindly is going to limit that life with some consequence. And then IPM, or Integrated Pest Management, provides this framework that can guide pesticide use should it be necessary. All right, Holly and David, that's pretty much what I had to say. I'm happy to answer any questions if any have come up.
Oh yeah, thanks, Dr. Tooker. I'm just sitting here in awe of what you just said. One thing when we talk about through our soil health activity is trying to get producers to look at their soil as habitat. I like to tell farmers they're no longer farmers, they're habitat managers. It sounds like you kind of confirmed the view that I've been trying to advocate as I go out and talk around the areas that I work in. Would you kind of expound on that a little bit, or?
Yeah, I couldn't agree more, David. A lot of farmers see insects as part of the problem. Many entomologists see insects as part of the solution. So you can't take out the bad insects without taking out some of the good insects. But if you farm with the good insects in mind, typically they win. In that prairie system that I touched upon early, one of the reasons, again, we don't see pest outbreaks very often, or herbivore outbreaks, because you can't really call a herbivore doing its natural thing in a native system of pests. But the reason you don't see herbivore outbreaks very much is because they're kept in control by all the linkages in that food web. And I truly believe that with no-till, cover crops, diverse rotation, and IPM, those connections can be fostered in our farming systems, and the pest populations will go down. But we're not advocating for fields to be left vulnerable. By using IPM and scouting fields and understanding local pest populations can be dealt with rescue sprays.
Okay, well, just to kind of reassure you that as the NRCS, we talk about must-do conservation practices to fit into a soil health management system, no-till, cover crops, rotation. We also include integrated pest management and along with nutrient management as practices you have to do in order to have a system that builds and improves soil health. So there's a lot of questions related to neonics. So let me just kind of talk about, can you talk about the risk? I mean, what are they doing as far as water quality? Is there human risk to it? I mean, we've had some other discussions. I'm not sure the folks online today have had party to that. So could you talk a little more about that? maybe cost? Is there seed that you can buy? Just kind of maybe a little more general discussion on that.
Sure. Well, I think you touched on a couple things, but let's hit the pollution first. So about 95% of the insecticide coated on an individual seed does not end up in the plant. So that leaves about 95% of the active ingredient in the field and vulnerable to leaching. And these are water-soluble compounds. So they're carried away by over surface flow, by subsurface flow. They get into adjacent agricultural streams. They get into vernal pools. They get into rivers with kind of unknown effects. Research is just starting to come out now showing the kind of chronic effect of pollution by these things. I guess there's a lot more to learn there from research, but it's clear that the insecticides are most places that people look because they're water soluble. And the questions I usually get is, yeah, I'd like to use untreated seed, but 90% of the seed out there is treated. How do I do that? One, as David mentioned in our conversation before the phone call, you have to order early. You also have to be kind of a pain in your corn or soybean seed seller's neck. You have to really push for it. These untreated seeds are in limited supply, but they're out there. And in Pennsylvania, I found that the smaller seed companies, the regional seed companies, are far more responsive than the really big national companies. And the smaller companies see an untreated seed as a niche product, and they can provide that. If folks were interested in specific companies in Pennsylvania that they can go to have a better chance of getting untreated seed, I can give a list of that, but understanding that we have the kind of the whole country on the line, I'm not going to go into those types of details. But I assure you that the small seed companies in your neck of the woods is more likely to be able to provide these and won't give as much pushback. So I've heard many stories of farmers that want untreated seed, but they go to their seed dealer, and the seed dealer provides a little bit of pushback. Like, you really want that untreated seed? Why would you leave your crop vulnerable to that? And as I say, the pests that are being targeted are pretty darn spotty. And if you have a good grasp of your field history, you have a sense of where these things will be. So those insecticides on seeds could be better targeted to those spots. I'm not sure that's everything you wanted me to touch upon, David, but just tell me what I missed.
No, I think you covered that. I guess if those neonicotinoids go after the secondary pests, I'm a little shocked that they're so widely used. I mean, do most farmers know that? It sounds like you're going after minimal risk with those for some reason. And does that make sense?
No, what you said makes sense, but the general mindset in my mind doesn't make sense. So yes, we are targeting secondary pests with these compounds, and they're being deployed on almost all the corn acreage and over half the soybean acreage, and then you can pull wheat and cotton in there if you like. But a lot of growers don't recognize the benefit that they gain from them. One, it's because it's difficult to know what the benefit is. You don't know that the pest was there. You don't know that you're gaining control. But a lot of farmers assume that they are gaining control because they don't see a pest problem. But the absence of a pest problem doesn't mean that there was a pest there and that the insecticide controlled it. It could well mean that the pest was never there. And in our research, that's what we tend to see. It is also the case that many, many farmers don't know what's on their seeds. They don't even know that that's what they're buying. And I understand farming operations are complex, and they have a lot of details that need to be attended to, and what exactly is on their seed might not be their foremost concern because they often trust their seed dealer very well. They often have a close relationship, and if they're given the suggestion that this particular well-coated seed is the way to go, they'll go with it without really questioning it. I'm not impugning farmers for doing that, but it would be better off if they knew what they were using and that they're controlling a very small number of pests and that the window of control is very short. A colleague of mine, Christian Krupke, who I believe was on a webinar like this a couple weeks ago, has revealed that you get about 2 weeks of control. That's when the insecticide is detectable in the plant, not the 45 to 60 days that's being marketed by a lot of the glossy promotional materials out there.
Yeah. Well, I really appreciate that. Let's ask a couple questions about cover crops. is there a way, some people see cover crops as a host for potential pests. Others see them as a way to treat, attract beneficials. How do we know the difference?
Well, again, on balance, the good insects tend to win. So I think slugs have been valuable to me because they provide what I see as kind of a worst-case scenario. Because what slugs are a very difficult to control pest. Again, you can't buy very many things to spray on them. You need kind of a systems approach to deal with slugs. At least that's what our researcher has shown. So if we can manage slugs, we can manage most any other pest species. And slugs need to be managed with cover crops. So the more diverse the rotation with cover crops in the system seems to drive slug populations down because of the natural enemies. So on balance, cover crops provide more habitat for good insects than they provide harborages for bad things.
You mentioned ground beetles as being good for controlling slugs. Is there any other beneficial insect out there that we could encourage to come into the system?
Yes, but one thing to recognize is that kind of specific things it's difficult to attract a specific type of beneficial organism. So just farming with all the animals in mind kind of brings them all in. But just if you were to add to the list, firefly larvae are supposed to be good slug predators. Soldier beetle larvae are supposed to be good slug predators. Some wolf spiders will occasionally eat slugs. There's some rove beetles that'll eat the smaller slugs. So there is this diversity of things out there, and just farming with good habitat in mind is an approach to attract as many as you can, then using IPM layers on top of that.
What about stink bugs? Are they pro or con when it comes to cover crops?
So we've had some challenges with stink bugs in Pennsylvania, but it's very specific. So we've had challenges in crimson clover before corn. But we haven't seen the same thing with cereal rye. We haven't seen the same thing with some of the vetches. So it's very specific. So I don't have a broad concern about cover crops and stink bugs. I have a specific concern with crimson clover and stink bugs, and we're still conducting research to figure out exactly what's going on there. But it does seem in our research that crimson clover can make stink bug populations in corn worse.
Good. Kind of back to the beginning of your presentation, you talked about pesticides being reviewed. Are they reviewed for their impact on the microbial communities of the soil, or is that something that's not done as part of the regular review process?
David, I don't know that. I don't think they are, but they may. I'd have to look that up.
Okay. Okay, and then just one quick question, and then I see where our time's about run out. Wireworms, is there any tips on how to scout for them and sampling, determining economic thresholds, or a good publication that can be referred to?
Sure. So the research group that has done the most on wireworms recently is a group at the University of Guelph Ridgetown campus, and they're doing, in collaboration with the Ontario Ministry of Ag, have done a lot of work on wireworms. And wireworms they're kind of this ghostly pest that a lot of people are concerned about. In my work, I've gone scouting for wireworms time and time again and rarely find them. To scout for wireworms, I use flour bait traps. So essentially you dig a hole, you put a cup of flour in there, and you cover it back up, put a flag there, and come back a week later and see if you have wireworms. My experience has been in kind of rotational systems that have been rotated for a long time. Wireworms are rare. If they're going to be common, they'll be common along the edge, kind of close to the farm lane. But they're more problematic when you're coming out of pasture or you're coming out of hay, say into corn or soybeans. So there, a targeted use of insecticide on the seed might be valuable. But if anyone's looking for particular information on wireworm thresholds and scouting protocols, the University of Guelph Ridgetown has a group led by Art Shafsma that has done the most of anyone that I know. Purdue University also has some good information on wireworms.
Okay. With that, I think I'll draw the questions to a close. And again, I think it's been a very informative webinar, and I appreciate you taking your time, and look forward to more great work coming out of your efforts up there at Penn State. And with that, Holly, I'll turn it back over to you.
Okay. Thank you, John, for making the presentation today, and thanks, David, for coordinating this webinar, and thanks to all of our participants for joining in. We had more than 220 people join today's webinar. Participants, to provide your feedback about the webinar, and if you selected to earn CEUs, please return to your open browser window to continue the process that's offered by Step 2 at conservationwebinars.net. This concludes our webinar.